Hey everybody, we are doing the second half of your notes for the Pythagorean Theorem, and we're basically just going to be working through some problems. And although most of these problems are very easy ones that you may have seen before, we're going to quickly go through them. Then we're also going to do a couple examples on the back where the answers don't work out as perfect squares. So we're just going to start with the very first one. So your notes: the hypotenuse, which you should know from all the talk we've done with this, of a right triangle is 10 inches, and one of its legs is 6. That means I can pick whichever one I want. I can say that one's 6, I can say this one's 6, and we're trying to find the length of this other side right here. So here's a good strategy for doing this. Take the two numbers they give you, square them, always writing the bigger number first. Okay? Notice I did not put my plus or minus sign here. I'm going to wait on that step because that will keep me from trying to actually do math with the 10 and the 6 before I've done the exponents. Again, I have to do exponents first because that's order of operations and we follow that all the time. So 10 squared is 100, 6 squared is 36. Now, knowing that I'm looking for a shorter side, that I have to add or subtract one, I got to do one of those two things. Well, the fact that I'm looking for a shorter line tells me to subtract. So I get an answer of 64. Now obviously this line is not 64. To find the answer to this, we have to do the square root of 64, which is 8. And that answer makes sense. That is 8. It's smaller than it's shorter length than the 10, which it has to be, again, because that line has to be the longest. Okay? Next question, and a very popular one. It says the base of a 26-foot ladder stands 24 feet from a house. Okay, so we draw our little house here. And we say that the base of that ladder is 26 feet from the house. So that means it's here. Sorry, the base of a 26-foot ladder. So from the base of the ladder to the building is 24, and it says the ladder is 26 feet long. So how many feet up the side of the house does the ladder reach? Well, look at that. We got our right triangle, and if we know this, and we know we're looking for this side right here, we know that that's what we're going to be using, our Pythagorean theorem. So we're going to write down the two numbers we're using, writing the biggest number first. 26 squared, I believe, is 676. I hope so. 24 squared, I believe, is 576. And some of these are kind of popular, and you'll begin to recognize them as, you know, the more we work with them. So if we get those two answers, we've written them down. And again, we're looking for a shorter side, so it only makes sense that we subtract those two answers from each other. And that's why we wrote the bigger number first. And so we get an answer of 100. The square root of 100 is 10. And that answer does make sense. And the reason I say, does that make sense, is because we need to ask ourselves at the end of questions, did the work I just do match the question I was asked? So, since I am simply doing the Pythagorean theorem, and I know that the ladder is pretty long and it's leaning up against the building, and I know that side has to be shorter, that 10 does make sense. Okay. Now this problem, although it involves the Pythagorean theorem, actually asks us to find the perimeter. So we have to actually find what this line is. And again, this is going to be our C because that's the longest line. And when we do that, we'll be able to find out what the perimeter is. Okay? So we're going to take our two numbers they give us. Again, we're going to square them, writing the biggest number first. So 12 squared is 144. 5 squared is 25. Knowing that I'm looking for the longest side tells me to add those two numbers, which gives me 169. And the square root of that, which you may not know, but it's 13. Now, if you were doing this problem on a test, I can almost guarantee that one of the answers would be 13. But they want to make sure that you're actually looking back at the question and answering the question. What is the perimeter? So if our C is 13, and we have to do the perimeter, 13 plus 12 is 25 plus 5 gives us a perimeter of 30. So that would be the correct answer for the question that they asked us. That would be the one that you would highlight when you're using your highlighter on your tests. Okay, number 4 up here to the top. Julie is trying to arrange 3 squares so that they form a right triangle. Remember, whatever this area is added to this area has to equal this area. That has to happen for the right triangle to be formed. So it says the small square has an area of 81. And hopefully from that we know that that means this side is 9, because 9 times 9 is the area of 81. It says that the large 1, which means large square, has an area of 225. So this is an area of 225. Although you may not know that yet, eventually you will kind of remember this one. That means that length is 15. And it says which of the following could be the side length of her third square. So we're looking for the side length. Very important. I bet one of these answers is the answer to the area of this. So we've got the big area, we got a small area. We're going to subtract to find out that the area of this medium size square is 144. And look at that. That just happens to be one of the answers. But again, that's not what the question asks you. It says what could be the length of her third square. So the length is what we're looking for. So the square root of 144 is 12, which is how long that line is. And we've got answer B for that one. Again, that's why we have to be really careful with answering the question they ask us. And the last one, example 5. If you have a TV cabinet which has a width of 8 and a length of 6, would a 9-inch television fit in there? Again, when we talk about how long or how big TVs are, we're talking about the diagonal line which goes across them, which if we do all this extra drawing here, we should see that they're talking about the hypotenuse, or the letter C, of a right triangle. Yes, I know this would be a very small television, but we're just trying to do a question so you see how they might ask you a question like this. So I've got my two sides. 8 squared I wrote first, and 6 squared. I wouldn't normally put that plus sign there, because what happens is people will sometimes add those two numbers together first and try to do 14 squared. Well, you can't do that. You have to square them separately because of order of operations. So 64 and 36 is 100. The square root of 100 is 10. So that means our line from here to here is a length of 10. So if we were trying to put a 9-inch television, it would fit. If it had come up with an answer of 8.5 or something, then that television would not have fit. It would not have fit between here. But since it's a 9-inch television and this line is 10, it does fit. Okay, turn over your paper. We're going to do one more example, and the reason I'm doing another one is because I want you to see how we have to put together what we did the other day when we did finding the area. I'm finding the as close to the square root of a number by estimating as we can. So I'm going to give you one where the numbers don't work out perfectly. Okay, so we're going to do 17 and 12. Okay, I'm looking for my longest side, so I'm going to take the two sides they give me, and I'm going to square them. 17 squared, 289. 12 squared, 144. When I longest line tells me to add them. Okay, so I might have to come out here and do a little addition, because not all these you can do in your head. So I get an answer of 433. So that means I have to find the square root of 433, which nobody knows off the top of their head. No one's going to just be able to rattle that number off when you ask them. So we have to actually use some of our strategies. Let's see. 400 is a very common one because it's 20 times 20. So that's one we could start with. And the one below it is 21, which is 441 when we square it. So now we can make a decent estimate at the actual number for the C. Well, it's 20 point something, but it's a lot closer to this one than it is to that one. So we probably would want to guess about 20.8, 20.7, 20.9 would be close enough. We wouldn't want to have an estimate much lower than that, because that would mean it was way closer to the 400 than this. So we could estimate that this length is about 20.8. And that would be a pretty good example, or a pretty good answer. And I'm going to quickly do 20.8 here on the calculator, and I'm going to tell you what it is just to see how close we did get. it's 400 and pretty close, 432.64. So pretty close to 433. So when our right triangles don't always work out perfectly, and sometimes we have to do this. So we're going to be doing a lot of practice with this in class, so be prepared and work hard and you'll become a master at this. All right, we'll see y'all. Bye-bye.